In this video, we're going to discuss the atomic numbers and the mass numbers for different atoms. So atoms are, of course, composed of protons, neutrons, and electrons. Where protons are positively charged particles, neutrons are neutral or uncharged particles, and electrons are negatively charged particles. The protons and neutrons in an atom make up what is called the nucleus. The nucleus is relatively small and dense and located at the center of the atom. So even though the nucleus constitutes most of the mass of an atom, its volume is relatively small compared to the volume of the entire atom. So the mass of the nucleus determines the mass of the atom. And this is because a proton or a neutron is almost 2,000 times more massive or heavier than an electron. So electrons are very light compared to protons and neutrons, and therefore the mass of an atom is determined by the mass of the protons and the neutrons in that atom. So let's talk about a few definitions. First of all, the atomic number, Z, is the number of protons in the atom's nucleus. The mass number, abbreviated as A, is the sum of the protons and the neutrons in the atom's nucleus. And an isotope is atoms that have the same atomic number but different mass numbers. So isotopes are atoms with the same number of protons but different numbers of neutrons. So let's start by discussing the atomic number a little bit. A few facts about the atomic number, a few different ways to define the atomic number. The atomic number is equal to the number of protons in an atom. The atomic number determines the identity of an atom or element. The atomic number is the same for all atoms of an element. And the atomic number appears above the symbol of the element on the periodic table. So here you can see an excerpt from the periodic table. Here's the symbol for sodium, and the atomic number appears above it. And also the atomic number is always a whole number. So let's take a look at this periodic table. Here we have boron. The atomic number for boron is 5. That means that all boron atoms have 5 protons. If boron were to gain a proton, so it had 6 protons, now it's no longer boron, it is carbon. So the number of protons determines the identity of an atom. All carbon atoms have 6 protons, atomic number of 6. All nitrogen atoms have an atomic number of 7, etc., etc. A quick word about electrons, even though we're focusing mostly on protons and neutrons. Atoms have the same number of protons and electrons. So for each positively charged proton, there is a negatively charged electron. So atoms that have the same protons and electrons we say are neutral, or they have a net zero charge. Now there are atoms that can gain or lose electrons, and when they gain or lose electrons they're called ions. But for now we'll discuss ions more in a different video. But for neutral atoms we can assume that the number of protons and electrons are the same. So let's take a look at a problem related to atomic number. State the number of protons in each of the following. Now get a periodic table, pause the video, and answer these 3 questions. So if we look on our periodic table for nitrogen, we see nitrogen has an atomic number of 7, so it has 7 protons. Sulfur, if we find it on the periodic table, it's right here, sulfur, atomic number of 16. So sulfur has 16 protons. And barium, if we look on our periodic table for barium, we see barium has an atomic number of 56, so it has 56 protons. So let's go ahead and discuss mass number and isotopes a little bit. As we said with mass number, there's a few different ways we can define it. First of all, the mass number represents the total number of particles in the nucleus. We could also say that the mass number is equal to the number of protons plus the number of neutrons. Or rearranging that, if we need to figure out how many neutrons an atom has, we can take its mass number and subtract its atomic number, and that will give us the number of neutrons. So be sure you are comfortable with this mathematical formula for calculating neutrons. Like the atomic number, we can't have a half of a neutron, so the mass number is always a whole number. The mass number does not appear on the periodic table. Unlike atomic number, it does not appear. The number of neutrons does not have to equal the number of protons in an atom's nucleus. So we can have atoms that have more or less neutrons than it does protons. And finally, the mass number is not the same as the atomic mass. Now, we'll talk about atomic mass later, but this is something you may want to just make a note of for now. So now let's talk a little bit about isotopes. Isotopes are atoms of the same element that have different numbers of neutrons in the nucleus. Put another way, isotopes are two or more atoms with the same number of protons. So they're the same element because they have the same number of protons, but they have different numbers of neutrons. So here's an example. Here we have neon, neon 20. This is one way to represent an isotope. We have the element neon dash 20. 20 represents the mass number. So here we have neon with a mass number of 20, neon with a mass number of 21, and neon 22. Each of these are the same element. They're all neon, and they all therefore have 10 protons. And we can tell that by looking at a periodic table. Neon has an atomic number of 10. Now, we also said that most neutral atoms have the same number, all neutral atoms have the same number of protons and electrons. So neon has 10 protons, so therefore it has 10 electrons. But because each of these neons has a different mass number, they have different numbers of neutrons. So here, this neon isotope has 10 neutrons, and the mass number is 20, so 10 protons plus 10 neutrons gives us 20. Neon 21 has 10 protons, 11 neutrons. Again, 10 plus 11 gives us the 21. And 10 plus 12, so 12 neutrons, gives us the isotope neon 22. Despite having the same number of protons and different numbers of neutrons, even though they have the same or different numbers of neutrons, isotopes are chemically alike. So therefore, they react the same. So we can't distinguish between these neon isotopes by chemical reaction. So let's look at another way to represent isotopes. Here, let's talk about carbon. Here we have carbon 12. So we're talking about a carbon atom with a mass number of 12. We can also represent isotopes writing what's called an isotopic symbol. An isotopic symbol would look like this. Here we have the elemental symbol for carbon. We write its atomic number in the lower left-hand corner, and we get that, of course, from the periodic table. All carbon has 6 protons, and the mass number in the upper left-hand corner. So carbon 12, we know it has a mass number of 12. So it has 6 protons, 6 electrons, and 6 neutrons. Here's an isotope of carbon, carbon 13. So we know the mass number of carbon is 13, so we can write that up here. We write the elemental symbol for carbon, and then in the lower left-hand corner, we write the atomic number 6. So this isotope of carbon has 6 protons, 6 electrons, and 7 neutrons. Again, 13 minus 6 gives us the number of neutrons, which is 7. So let's try a few problems related to isotopes and mass number. Get a periodic table, pause the video, and answer these 3 questions. Okay, so how many protons does zinc atom have? Well, we can look on a periodic table and find zinc. If we find zinc right here, we see its atomic number is 30. So therefore, we know that it has 30 protons. How many neutrons does the zinc have? Well, its mass number is 65. So 65 minus the number of protons gives us 35. Remember, this is protons plus neutrons. Subtract the number of protons, and that gives us 35 neutrons. What is the mass number of the zinc atom that has 37 neutrons? Well, we know its atomic number protons is 30. Its number of neutrons is 37, so add those together to get the mass number of 67. Okay. Let's try another problem. Again, take a look at your periodic table, pause the video, and try this one. Okay. So an atom with 14 protons and 20 neutrons, its atomic number, well, the atomic number must be 14, right? Its mass number, we add protons plus neutrons, that gives us 34. And what is the element? Well, the element, as we mentioned before, it's defined by the number of protons. So if we look on our periodic table, find here, 14 protons gives us the element silicon. Okay. And let's take a look at one last problem. Assume that these are neutral atoms, so the protons and electrons are the same, and see if you can fill in this table. Pause the video and see if you can fill in the table completely. Okay, so here we have silicon. Its atomic number, remember the atomic number is down here, that's 16. The mass number is in the upper left hand, 32. The number of protons is equal to the atomic number, 16. Now, to get the neutrons, we subtract the atomic number from the mass number. That gives us 16. That was given. And the number of electrons, assuming that they're the same as the protons, would be 16. Now here, what element is this? Well, the atomic number is 7. That's using our periodic table. That must be nitrogen. Its atomic number for all nitrogen is 7. And this nitrogen isotope, or this nitrogen atom, has a mass number of 14. Number of protons is 7, neutrons is 14 minus 7, and electrons is 7. Here, we're given the atomic number, so we can identify the element with an atomic number of 17 as chlorine. The mass number, which is in the upper left, we get that by adding the protons plus the neutrons, so our mass number is 35. We write that here and here. And the electrons would be 17. And finally, let's look at this one. Again, what's the atomic number? Well, we have 20 electrons, so we can assume 20 protons, an atomic number of 20. That defines the element as calcium. Atomic number is 20, mass number is 40. So the number of protons is 20, and the number of neutrons must be 20. So again, be sure you understand these definitions and can work some of these problems like you see here related to atomic number and mass number.